Yeah. So replication controller. So what is the replication controller? It is a Kubernetes component which is used to create the pods. Okay. It is a Kubernetes components which is used to create the pods. It will make sure always given number of pods are running for our application. So it will take care of the pod life cycle. When the prod is crashed or damaged or deleted, then the RC will create a new pod. So we can scale up, scale down the count using replication controller, replication.yaml. So what is that replicas? Your containers. How many containers we need to run? Your containers will be running on how many? Three containers will be running. If something goes wrong, if it is one pod is crashed, it automatically create another pod. One um, one container is damaged, it will automatically created another one. If it is deleted, it automatically created another one. So your replicas means you need to, if it is a down, it will automatically create. So it will damage, it will automatically create the another container. That's the reason. So replication controller. Guys, understood? Understood? Yeah. So how you can create the RC data image, something like a, what is that? Pod SVC RC dot unlimited. So namespace also, right? So you can create the namespace. Huh? So can pod SVC RC dot unlimited. VM. So what is this, right? Here what we have? So we have a selectors. So replica specification. In this specification, there is a replicas 3. In this replicas, there is a selector of. So metadata, my name is Tomcat, label equal to app Tomcat. Okay. So this app name is selected to the selector. Okay. So container, my name is equal to Tomcat, images Harikrishna Tomcat, code container 80. So in the service, you provided the load balancer and the selector equal to app. What is the selector? The selector represents the label. So if you call the selector, it will automatically connect to the label and will create the path. Right. So
Sorry,
what this is?
two specifics ఉన్నాయి సార్ టూ స్పెక్స్ ఫైల్స్ ఉన్నాయి సార్
Huh? Two specs. One spec is for replicas. One spec is for replica. Another spec is for container.
ఓకే
You see, one spec is for replicas and selector. So another spec is for containers. Okay,
ఓకే సార్
understood.
ఎస్ సార్
Okay. So this is a replication controller. Let's see. API version kind metadata spec replicas 3 selector app my tomcat template metadata name labels app again spec containers. So that API version. Yeah. So this is the API version. Yeah. Right. So how to delete all? kubectl delete all all. It will delete everything, right? So apply kubectl apply hyphen pod svc rc dot yaml. Right. So replication controller, my tomcat is created, service my tomcat is created. Okay. kubectl get parts hyphen o wide. Okay. How many pods are running? How many containers? How many pods are running, guys? How many pods are running? How many pods? How many replicas?
Three.
Three replicas. So that's the reason. Clear running. Clear running. kubectl get yes, yes. Yeah, load balancer is created. kubectl kubectl get rc. So RC means replication controller. So desired 3, current 3, and ready 3. Okay. So is 65 seconds. So desired you said 3. Desired means minimum 3, current 3, ready 3. Okay. We want to scale up this RC. kubectl scale RC Java Tomcat, right? Tomcat 9, Tomcat 9, definition replicas 5. So not from application controller, Tomcat 9, Tomcat 9. So what is that, guys? So application controller, my Tomcat 9, right? It's my Tomcat 9, not kubectl scale RC Java Tomcat 9, icon replicas, replicas 5. Because my Tomcat 9 is not good. Institute. It's a controller. My Tomcat phone. Click CT. Get first. This is the my Tomcat, right? My oh, so the name is my Tomcat. Sorry, this is a no. It has it. How many desired by? So it will increase. It will decrease also. Because 3. We need to decrease to 3. It will decrease. 3. So right, I already told you that a replication controller is a old method. So we have a replica set. So replica set I already told you, right? So replication controller having only, so replication controller, so only having one selector, only having a one selector, but the replica set supports set based selectors. Replica set supports set based selectors. I already told you, right? Replica set. So replica set is a replacement for the replication controller. It is a next gen component, Kubernetes component. Replica set is also used to manage pod lifecycle. Replica set also will maintain a given number of pod always. So we can scale up and scale down our pods using replica set also. So the only difference between replication controller and replica set is selector. So right. So the only difference is selector. Here only so application root application control support so if you continuous selector. What is that? Selector. Now make count. Okay. But replication support set based selector. Replication support set based selector. For example, selector. So what is the test? Manage labels. So here manage labels. Now, count that me. Right. So here, so replication support the set based selector. What is set? App equal to my Tomcat, version equal to v1, type equal to backend. So match labels. Right, understood. So here only selector here. So set based selector. So we need to set the versions, apps, or types. So set based selector. So replication supports set based selector and replication controller supports equality based selector. Selector app of my Tomcat. Guys, understood?
Yes, sir.
So how you can create a replication replica set? So replica set. So this is related to replication control. So what is the replica set? The replica. Just on the right. Because yeah. So replica set. This is the app version. So app version apps kind replica set. Metadata, something like Nginx web app RC. So spec containers, match labels Nginx web template Nginx labels. This is a spec. You see, guys. So in the selector, you use the match labels. The match labels app Nginx web, but in the match labels, you provided the Nginx web. Okay, the container nginx, image equal to nginx, port equal to container. So this is the replica set. Right? See. Yeah, and equal to API version. API version. Replica set to name equal to nginx web app RC. Replica so selected match label. This is the one guys. App nginx web app template, metadata, name, labels, app. Suspect containers, engine expect container, container port equal to 80, API version V1, client service, metadata equal to nginx, SVC, type node port to, selector nginx web to, port to, target to. Okay. Okay. Yes, understood?
Yes.
Again, kubectl, delete all information, all request. Kubectl, apply, make me, let us set that. Yeah, it's created, right? kubectl, then parts, include this is part. This 1 is equal to R is equal to 0, right? So this is nothing but a, this is nothing but a, can you tell me what this is? 80 port number 80, right? Let's see. Ninety-two, 168, 56, 232. If you listen, 237. Next, So what is next? What we discussed? We discussed about the deployment, right, guys? Deployment. Keep city, delete. If and avoid this, if you delete one point, automatically create the form. Let's try to delete. Okay. So deployment. What is the deployment, guys? What is the deployment? Deployment is one of Kubernetes a resource or component. Guys, be carefully, listen carefully. So while real time, we are using this only deployment. Deployment is the most recommended approach to deploy our applications in Kubernetes cluster. Hmm? Kubernetes cluster. Understood? Using using deployment, we can scale up and we can scale down our pods. Can scale up and scale down our pods. Okay. Using deployment, we can scale up and scale down our pods. Using deployment, the most recommended approach to deploy our application is Kubernetes. Deployment is one of the Kubernetes resources or components. Okay. So using deployment, deployment supports and supports rollout and rollback. Note, it is a note, guys. To deploy latest code, we have we have to delete delete twice, then pods will be created. Pods will be created. Pods will be deleted and application will be down. Right? Down. Right. So something like what we can do. So we can deploy latest code with zero downtime using deployment. So zero downtime deployment, rollout and rollback, auto scaling now. So everything is there is no. So deployment strategies we have below deployment strategies, recreate and rolling updates. What are the best suitable deployment stories strategies? Recreate and rolling update. Recreate means it will delete the existing parts and it will create new parts. And your time will be there. So rolling update is nothing but a strategy means it will delete the pods, create a new pod one by one. If you don't specify the deployment strategy, by default, you consider as a rolling update. Rolling update. So rolling update means so if you have a five microservices, so it will deploy the first microservice and it's stable. Then only we can shut down the second Docker container. Okay. So rolling out the strategy means it will delete the pods, create a new pod one by one. And if we don't specify a strategy, then by default we will consider as a rolling update. So right. So this is the rolling update. Okay. So what is that? Deployment, right? Deployment file. Is the deployment file. So Kubernetes deployment manifest file. So pod manifest, service manifest. So cat deployment.yaml API version apps v1 and equal to deployment metadata Nginx web deployment replicas 3 strategy 3 days recreate and the sector matches notification. So when we start the start it, it will create a Nginx web app labels. So this is the Nginx web app. So service is equal to node. Okay. So this is the deployment layer. What is the deployment manifest?
సార్
Yeah. Right.
సార్ ఇప్పుడు రెప్లికేషన్ కంట్రోలర్లో మనం ఓన్లీ ఒకటే యాప్ ఇస్ ఈక్వల్స్ టు ఎన్జిఎక్స్ అని ఒకటే రాయగలం సార్. రెప్లికా సెట్లో మాత్రం ఎన్నైనా రాయొచ్చు సార్.
Replicas లో ఎన్నైనా రాయొచ్చు.
దట్ ఈస్ ద ఓన్లీ డిఫరెన్స్.
Pod service manifest there is no concept of replication. When it replica starts from replication controller, then replica set. Okay. 1 second. Hello. Hey guys. So this is the deployment file. So what it contains? Kind is a deployment, right? So how many replicas we need? Three replicas we need. So what is that strategy, guys? What is the strategy? So what is the strategies? We have a two types of strategies. So one is yeah. So what is the strategy? Deployment strategy, guys? In the deployment strategy, what is the files, guys? What is the YAML file? The YAML file is a deployment strategies. What is the YAML file? Deployment manifest. In the deployment manifest, what we will create, we will include. So we will include the recreate or rolling update. By default, Kubernetes. So what we will get? We will get the rolling update. So what we will get? We will get the update. So recreate means it will delete all the existing pods and it will create a new pod. So downtime will be there. So rolling update is a strategy means it will delete the pods, create a new pod one by one. So if you don't specify the deployment strategy, then by default it will consider as a rolling update. So what is this, guys? This is a recreate and this is the rolling update. What is this, guys? This is a recreate and a rolling update. Rolling update means so it will delete one and create one, delete one, create one, delete one, create one. Is understood? See, what is the deployment strategy? The deployment strategy is recreate. So what is that? Spec replicas. So replica set. This is a replica set, and this is the deployment strategy. What is your kind? Kind equal to replication controller or kind equal to deployment. So deployment strategy, right? That's the reason we are creating deployment. So recreate or rolling update. So recreate or a rolling update. Understood? Guys, understood? So this is nothing but a deployment strategy type equal to strategy. So match labels and Nginx web app and that labels name equal to Nginx web app. Okay, container port service Nginx node port Nginx port equal to 88. Understood? So this is nothing but a deployments. So deployment. So what is that? So next is so what is that? Next is blueprint deployment model. What is next? Next is blueprint deployment model. In the blueprint deployment, what we will do, guys? So it is one of the approach now to deploy application. It is one of the approach to deploy application. What is the less risk? Sorry, what is that? Less risk. What is the second one? Yeah, guys. Less risk to zero downtime. Third one is easy rollbacks. Fourth one equal to seamless user experience. We need to create below manifest YMLs for blue green. So blue green deployment. So guys, what you can do is something like it's a so blue green deployment model, live service model, green deployment model, pre prod. So you can create that deployment model. So I already told you, right, guys? Yeah, all kinds something like how you can create the so strategy. So deployment model, strategy equal to record and strategy equal to rolling updates. Okay. So blue green deployment model, black white deployment, red block deployment. These all are the strategies only. Kubernetes does not have any relation with this deployment, blue green deployment model. This is just a generic approach to deploy our application in the production. So what is the strategy? So the Kubernetes strategy is only rolling update and recreate only. Okay. So this is the just a generic approach to deploy our application in the production. So what is blue and green deployment? Blue-green deployment is an application release model. It reduces the risk of minimum downtime. It uses production environments known as a blue-green deployment. So blue-green deployment, the old version can be called as a blue environment. The newer version can be known as a green environment. Advantage with the blue-green model, a rapid releasing, simple rollbacks, built-in disaster recovery, seamless customer experience, zero downtime. Okay. So what is this? So here, so this is our, we needed two Kubernetes environments. One is for blue, another one is for green. So something like, so the users will through the router, if the application is in running in the blue, it will, the router, that DNS will be pointed to the blue green. So if the, so something like you created a new feature and you deployed in the feature in the green deployment model. So that DNS will be routed to the green deployment model, then go to the shared resources. Okay. So user one, user V1 and user V2. So something like user V2, new release, V2 it will be deployed on the green. So V2 is deployed. So users are seeing CV1, right? The users are using V1. So V1 is still running. So blue environment. So then the green is live. So once the DNS is routed, then directly go to the green deployment. So advantage of the blue green model. So rapid releasing, simple rollbacks, built-in disaster recovery, seamless customer experience, and zero downtime. So the practical you already know, right? A blue green deployment. So deployment procedure, create a blue deployment, expose the pods using live stream, etc. So this is the blue green deployment. So next one is config maps are secret. What is a config map? What is a secret? For every application, multiple environments will be available for the testing purpose. DevOps, UAT, pilot. So once the application testing is completed in all the environments, then it will be deployed in the production environment, live environment. For every environment, application properties will be different. Database properties, Kafka properties, FS, SMTP, right? So the configs and secret. For example, your password is secret, right? A config map. So config map means your database username will be same on all the environments, but the password is different. So right, once the application testing is completed, all the environments, then it will be deployed to into production environment, live environment. So for every environment, application properties will be different. Database properties, database username properties, secret username, password. So Kafka properties, so SMTP properties, everything will be different. Config map secrets. We should not hard coded the application properties. Config secrets concepts are used to avoid hard coded properties in the application. So config map is used to store data in key value. What is that, guys? So the config map is used to store data in key value, non-confidential. So config map allows us to decouple the application properties from Docker images so that our application can be deployed into any environment without making any changes for our Docker image. So what is that, guys? In the GitHub, there is a code and the properties. So the code plus properties will create the var and then Docker image. So it's like a config map will make Docker images as a portable. Okay, secret. Secret is also one of the Kubernetes resource. Secret is used to store confidential data in key value format, password, for example. So secret is used to store confidential data in encrypted format. So encrypted format. Our app will be read environment specific to properties from config map and secret one. So this is a GitHub code and hardcoded properties where Docker image. So and Kubernetes cluster prod and SVC. So GitHub the prod and dynamic properties where images or Docker images prod config and secret. So config manifest file. So API version kind equal to config map metadata name equal to so vShopify DB config map label equal to storage vShopify DB storage. So data equal to DB driver name value, DB service name value, DB schema name value, DB port value, DB username value, DB password value. So right, so secrets. What is the secret of metadata? vShopify DB config dot secret label secret. So this is the database password, username and password. Okay. So example of a config and secret. So for example, this is our application container and this is MySQL database container. So URL SVC schema port and config map and secret username and password here config. So create a config map, create a secret, deploy MySQL DB container using config map and secret data. So test data is deployed or not. Deploy applications by reading config map and the secret data for the DB properties test applications. So stateless applications versus stateful applications. Browser, stateless application and stateful applications. So stateless application is nothing but our app applications are all the stateless applications. Stateful applications are the DB environment is the stateful applications. What is stateful sets? What is stateful set? A stateful set is the Kubernetes controller user to run the stateful application as a container or pods in the Kubernetes cluster. Stateful sets assign a sticky identity in order to number of starting from 0 to each pod instead of assigning random IDs for each replica pod. A pod is created by the cloning the previous pod data. If the previous pod is the pending state, then a new pod will not be created. If you delete the pod, it will delete the pod in reverse order, not random order. Okay, a stateful set is the Kubernetes controller used to run the stateful applications. What is that? Stateful applications as a container in the Kubernetes cluster. So, stateful sets. So, headless service, pod 1, pod 0, persistent volumes, persistent volume. So, persistent volume claim, persistent volume claim, persistent. So what is the difference between deployment and stateful set? So deployment will be create the pods with random IDs, but the deployment will scale down pods in the random order. So deployment pods are stateless pods. So the deployment pods are stateless pods. So stateful set will create the pods with a sticky identity. Stateful set will scale down pods in reverse order. Stateful set pods are stateful. Okay, so replication for application deployment will be used deployment. For the database deployment will be used the stateful set. Okay, so Helm chart. So what is the Helm chart? So Helm is a package manager for Kubernetes applications. Helm allows you to install or deploy applications on the Kubernetes cluster in a similar manner to Yum opt for the Linux distributions. Guys, understood? What is Helm? Helm is nothing but it's a package manager for Kubernetes application. Helm allows you to install and deploy applications on Kubernetes cluster. Helm allows you to install or deploy applications on a Kubernetes cluster in a similar manner to Yum opt for Linux distributions. Helm manages Kubernetes resource packages through charts. Helm manages Kubernetes resources. What is that? Helm manages the Kubernetes resources packages through chart, Helm chart. So Helm manages Kubernetes resource packages through charts. A chart is a collection of files organized in a specific directory structure. Okay, a chart is a collection of files organized in a specific directory structure. The configuration information related to a chart is managed in the configuration. Finally, a running instance of a chart with a specific config is called as a release. Helm is a package manager for Kubernetes application. Helm allows you to install or deploy applications on the Kubernetes cluster in a similar manner to YAML application distributions. Helm manages Kubernetes resources packages through charts. Helm manages Kubernetes resource packages through charts. A chart is a collection of files organized in a specific directory structure. The configuration information related to a chart is managed in the configuration. So finally, a running instance of a chart with a specific config is called as a release. So Helm package manager, Amazon Linux VM, Ubuntu Linux VM, M package manager, opt package manager, M install git, apt install git, M install Java, apt install Java, M install Maven, apt install Maven. Similar case, Helm architecture. So chart repository. What is a chart, guys? A chart is a collection of files organized in a specific directory structure. The configuration information related to a chart is information related to a chart is managed in the configuration. So finally, a running instance of a chart with a specific config is called as a release. So chart repository. So this is the chart repository is the client to the Kubernetes API server. Okay, Helm charts. Helm is a package manager for Kubernetes cluster. Helm is used to install required software in Kubernetes cluster. Helm will maintain charts in the chart repository. Chart means chart means collection of a configuration files organized in a directory. So microservices. So kubectl top nodes, kubectl top node, top parts. So by default, metrics service is not available. By default, metric service is not available. So metric server is the application that collect metrics from objects such as pods or nodes according to the state of the CPU, RAM, and keeps them in the time. RAM and keeps them in the time. Metric server can be installed in the system as an add-on. So you can take and install it directly from the repo. So Kubernetes monitoring. So we can monitor our Kubernetes cluster components using below softwares, Prometheus and Grafana. Prometheus is a open source system monitoring and alerting toolkit. For Prometheus collects and stores its metrics as time series data. It provides out of the box monitoring capabilities of the release container orchestration platform. So Prometheus is an open source system monitoring and alerting toolkit, which is an active directory ecosystem. Active ecosystem. It is a tool that allows you to analyze how your application and infrastructure are performing from the metric discovered it. Then Prometheus is a component. Prometheus components are written in Go. So using most of the dimensional data model with time series data identified by the metric name. So and the key value pairs. Okay. So out of the box features, use a very simple query language from PromQL. PromQL is a read-only and flexible query language. So read-only and flexible query language that that allows aggregation across any of the label is stored in its family software. What is a Grafana? Grafana is an analytics tool monitoring tool. So Grafana is a multi-platform open source analytics and interactive visualization web application. So it provides charts, graphs, and alerts for the web. We can connect supported data resources. Grafana allows you to query, visualize, alerting, and undertaking your metrics, no matter where you are to create, explore, and share the dashboards. And so Grafana will connect with your Power Prometheus for the data resources. So this is the now architecture. Okay, this is the Prometheus architecture. This is the Prometheus, Grafana. So ELK is nothing but Elasticsearch, Log Files, and Kubernetes. So what is ELK? Okay. So ELK. So Elasticsearch Log Station Kibana. So Beats, Redis, Kafka, RabbitMQ can convert into the logs. Logs will get search in Elasticsearch in the Kibana. So what is ELK? ELK something like ELK stack is a collection of three are open source products. Elasticsearch log station Kibana. ELK stacks provides a centralized logging in order to identify problems with servers and applications. It allows you to tells you to search all the things, so all the single place. So Elasticsearch is nothing but a storing logs. Logstash is nothing but a both a simple shopping, processing, and storing the logs. Kibana is nothing but a visualization. So what is LK app on log? So logging into the process of a storing application execution detail log file. So Elasticsearch, so Kibana, Elasticsearch, Logstash, then logs. Kubernetes. Okay, Fluent bit also same like auto scaling is a way of automatically scale up or scale down the number of compute resources that are being allocated to your application based on a remind. So auto scaling HPA, how HPA works. Okay, so auto scaling, install metric server, deploy sample app, create a service, deploy HPA, increase the load, monitor HPA, auto scaling, less users using. So if the process of increasing or decreasing infrastructure based on the demand, auto scaling can be done in two ways. One is horizontal auto scaling, another one is vertical auto scaling. So most of the people are using only which one? Horizontal auto scale means increasing the number of instances or systems. So vertical scanning is nothing but increasing the capacity of the system. So we don't need to increase the capacity of the system. So we will launch another instance and there we are studying that. Okay, horizontal scaling means increasing number of instances or computers. Vertical scaling means increasing the capacity of the system. Auto scaling. So, so auto scaling, horizontal pod scaling, vertical pod scaling, horizontal pod auto scaler will you call you up and down number of a pods replica of a deployment replica set or replication controller dynamically based on the web's metrics. Okay, CPU. HPA will interact with the metric services to identify a CPU memory utilization of pod. So note for the production, we will use the horizontal scaling only, not vertical. So horizontal scaling versus vertical scaling. So while horizontal scaling refers to add additional nodes, vertical scaling describes the add more power to the your current machine. More power means we need to add EC2 instance something like. So limit to CPU, limit some CPU, limit to CPU request. So CPU granted of the request granted of one CPU. Limit maximum 2 GB for CPU. So imagine e case, you already know the e case, right? Ingress. Ingress is the user to map external URLs to Kubernetes cluster service. Okay. Pods are accessible with the cluster. To expose pods outside of the cluster, we are using Service Connect. If you have three types of services in Kubernetes cluster, if you notepad on this, Ingress. Ingress is used to max external URLs to Kubernetes service. Pods are accessible within cluster. So expose pods outside of the cluster, we are using service concept. I have three types of services in Kubernetes, right? So what is that? So domain ingress, we will come to the services. Base understood? Yeah, this is nothing but a Kubernetes. Guys, from tomorrow onwards, we will show you the Jenkins part. Okay? Thank you guys. So we'll continue from tomorrow. Base understood? We'll continue from tomorrow. So tomorrow we'll start mostly Jenkins or GitLab, CAC. Okay. Thank you guys.